Hello everyone, and welcome back to another episode of the Internet Computer Developer Journey. In today's episode 2.5, Unit Integration and End-to-End Testing, we're going to be taking a look at the different types of tests and the different test workflows you can use to test your Canister code. Testing is important in any stage of your development workflow because you need to be able to find any errors or bugs that are present in your code before that code is deployed for production. Once code is put into production and users are actively using your code, it can be detrimental to their user experience if there are several bugs and errors that they occur when trying to use your product. For a more seamless user experience, testing is highly recommended. So in general, there are three types of code testing that can be done. There's unit testing, where tests are individual functions and calculations that are testing to assure that they generate the expected data or return the expected result. And these are called unit tests because they test a single unit of the code at one time. There is also integration testing, which can test several functions, calculations, or portions of the code together, and it tests how the different parts integrate with one another, hence the term integration testing. A common form of integration testing is known as continuous integration testing, or CI testing. This is very popular on GitHub in GitHub CI workflows that run when a PR or other proposed change is submitted to the repository to make sure that the changes being proposed aren't going to break the current workflow. And then there's also end-to-end testing. So end-to-end testing, as the name suggests, tests the entire app's functionality from end to end. So it tests the complete workflow, including buttons, forms, front-end assets, or any other components of the application. So first we're going to talk about unit testing, and since this developer journey is focusing specifically on Motoko development, we will start with Motoko unit testing. So the Motoko base library contains a series of test files that can be used for unit testing. They specifically can be used for individual types such as data type, text, array, or function. You can take a look at the full library of test files in the documentation link within this tutorial. There is also a test library called Motoko Matchers. This contains several packages that can be imported for additional testing functionalities. And so we can take a look at a brief example that uses this Motoko Matchers package. So looking at this simple unit test in this tutorial, we can see that the Motoko Matchers package is imported 3 times, and we are importing 3 different packages from that Motoko Matchers library. We are going to import the Matchers package, the testable package, and the suite package. Suite is used to define a simple test runner or test suite. Testable is used to provide functionality for unit tests to be compared. So to compare the result of one test's input versus the result to output. And Matchers is used to provide functionality for composable assertions that can be used in tests. So if we take a look at this code here, we import those 3 packages, and then we are defining a test suite with the term letSuite, and then we are just calling the suite my test suite, and then we are further defining that it is going to include nat tests or natural number tests. And then there are 2 tests defined in this suite. So the first test is going to define that the value of 10 equals 10, and we're going to pass the value 10 into this m.equals, and then so m.equals refers to this matchers library, and then this t.nat refers to this testers library, and we are testing that the output of this test is going to equal a natural value of 10. So this initial value that's being passed to the test is going to be tested that it equals type nat of 10. And then the second test is going to test that the value of 5 is greater than 3. And this is also going to pass the value of 5, and it's going to use m.greater than type nat, and then the value of 3. And then at the bottom here, we are using suite.run suite to run this test suite that we've defined. Now we can take a look at Canister unit testing. So in addition to the 3 packages that we used in the previous example, the Motoko matchers library also contains a Canister package that can be used to execute unit tests for the entirety of a Canister's code. So if we take a look at this example here, we can write a test that imports the canister. So we would have import canister. Canister here is the data type, and then canister name. So if we had hello_backend or whatever our canister that we wanted to test, we would put that canister name here. And then we are importing that Motoko matchers canister package, and then the matchers and testable packages as well. And then in this, we are going to be defining the canister's code that we want to be testing. So we are going to define our actor, and we are going to define a test batch size. So this batch size is going to determine how many times our test is run. And then we're going to define a test function. And in this test function, we are going to have 2 tests. So this first test is going to test the output of a function called greeting. So this function greeting is used in our hello world example. It simply takes the passed argument of type text, usually a name, and returns hello followed by that inserted text. So we're going to test that this greeting, if we pass the argument of Bob to that function, it should return hello Bob. So this test is validating that the output of this greeting function is going to equal type text hello Bob. And then we're also going to define a function where we expect the test to fail. So this is defining a test that should fail. And if we pass instead the text of George to the greeting function, it's not going to return hello Bob, it's going to return hello George. And in this case, we should ignore the output of this function since it is not the intended output that we've defined up here. So if you want to take a look at a more complex running example, you can also take a look at the unit tests that are used in this invoice canister example on GitHub under the invoice test unit subdirectory, and you can take a look at this test.mo file written in Motoko that has some additional more complex unit tests. Also, if you are trying to run large batches of tests that are long running, you can take a look at the Motoko big test library. Now, this developer journey series is focused on Motoko development, so we aren't going to dive into examples for Rust unit testing, but we do have documentation that can be found on Rust unit testing, and we also have the DFINITY Rust guidelines on testing available for you. And you can find those links in this tutorial. Another way to test your code is to use a platform called Pocket IC. Now, Pocket IC is a community developed project, and it provides local canister testing that uses a Python library on the back end. The cool thing about Pocket IC is that it allows you to write tests that simulate different scenarios that would happen on the replica. So you can write tests that simulate running on a subnet of 14 nodes or 31 nodes, or running with a different amount of cycles, or different parameters that would help simulate real-world test cases once your code is deployed on the mainnet. And you can find more about Pocket IC in the documentation on Pocket IC in our testing section. Another tool that can be used to test your code is Light Replica, which is another community developed project that is designed to feel similar to Ethereum's Truffle or Hardhat tools, if you are familiar with those. It creates a local node that is designed to replicate the behavior of a real ICP node, and it also provides additional logging and other functions that help assist with testing. And you can learn more about Light Replica in the documentation linked in this tutorial. So next we're going to talk about end-to-end testing, and for this we are actually going to start writing some code. We're going to write some brief end-to-end tests and take a look at how those work. So to get started with that, we are going to create a new project with DFX. I'm going to be using DFX 0.17.0 and newer, but if you're on an older version of DFX, you can utilize the instructions found in this tab. So for this, I am going to first make sure that DFX is running. So I'm going to use DFX start, clean background, and mine is already running. So I'm just going to suspend that process. Then we're going to use the DFX new command to create a new project called E2E tests. And for this, I'm going to use this interactive prompt to select Motoko as the backend language. And then I'm going to select no front-end canister since I am not going to be using a front-end canister for my end-to-end testing. And then I will not be adding any additional features. And so now we can use the cd command to navigate into our new directory. And now if we scroll down below those, we can see the next steps are setting up the project. And the first steps here are to remove the source subdirectory for the end-to-end test front end. But since I'm using DFX 0.17.0 and newer, I was able to choose no front end as one of the configuration parameters when creating this project. So by default for me, this subdirectory does not exist, so I can skip this test. But if you're using an older version of DFX, this step still may be necessary. And the same is going to go for the second step of removing this E2E underscore test underscore front end configuration in the dfx.json file. Since if we take a look at the project's dfx.json file for me, we can see that the only canisters I have to find are the backend canisters. So we have a dfx.json that reflects similar to the one provided in the example here. So next we are going to need to install a couple of packages. So we're going to use npm or node package manager, and we're going to install, and we want to use the flag save dev since we want to save these in our local development environment. And then we are going to install vi test, and then we are also going to use isomorphic-fetch. So these are two packages that we will be using for our end-to-end tests. So we'll give those a second to install. And then we need to open our package.json file. So it looks like I do not have a package.json file in my directory yet to edit, and I need to insert this test, vi test, into this package.json file, and I need the entire package.json file. So I'm going to go to this annotation here that points out that if you need this file, the full repo for this project can be found on GitHub here. So I'm just going to open this and navigate to this package.json file. So here's the full content. I'm going to copy the raw content of that, and then I'm going to just use vi real quick to open up a new package.json file. You select I to insert content, then use Command V to paste that content I just copied, and then I'm going to hit escape and then :X to save. You can also do that process in VS Code or another IDE, but since we're just working in the command line here, I chose to use VI. So now we need to create a new folder that's going to contain our test files. It's pretty common to store them in a subdirectory that's just called tests. So we're going to use mkdir, and then we're going to use the subdirectory src or source, and then we're going to create tests under that. So in the next step of our tutorial here, we're going to be creating an agent. We haven't touched on agents yet in our developer journey, and we haven't written any agent code thus far. But for this tutorial, it's just important to know that an agent is a library that is used to make calls with the Internet Computer Public Interface. So it's used to communicate with the Canister's public methods, and this is going to help us test our code. We will be covering agents in a future tutorial in the developer journey that dives deeper into agents and how to use them. But for this tutorial, you just need to understand that they are used to make calls to the Canister's public methods. So in our tests subdirectory, we need to create a new actor.js file. And so for this, I'm going to be opening up my VS Code, and I'm going to open this end-to-end tests subdirectory that we're working in. And then I'm going to navigate into my tests subdirectory that we created and just get this moved over. And then in this, we want to create a new file called actor.js. And I'll close my Explorer here so we can see this a little bit better. And now we can start writing our code. So first, we are going to import the DFINITY agent package for our JavaScript agent that we're going to be using. So we're going to use import actor HTTP agent. So these are the two pieces we want to be using from @DFINITY/agent. So that's our agent our agent-js package. Then we also want to import fetch from that isomorphic fetch npm package that we installed earlier. Then we also want to import canister IDs from our DFX local canister IDs.json file. And then we also want to import the IDL factory from our declarations E2E tests backend, E2E tests backend, and this should be our .did.js file. Okay, so once we have all of our necessary imports, then we are going to export const create actor equals async canister ID options. And then we're going to use this equal sign and then the greater than sign and use a curly bracket and press enter. And then const agent equals new. So here we are creating our new agent, HTTP agent, circle bracket, curly bracket, space, ... options, question mark, .agent options. Then we'll put a semicolon at the end of this. And then we want to await agent.fetch root key and use empty circle brackets. And then we are going to press enter. And now we are going to create the actor using the candid interface file, which is that declarations, which I have misspelled. So this candid file, which is this declarations end-to-end test.did.js file. So now we want to return actor dot create actor IDL factory, comma, curly bracket, enter agent, comma, enter canister ID, comma, enter dot 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 options question mark dot actor options, and then we should have curly bracket, circle bracket, semicolon, curly bracket, semicolon. So up until this point, so far we have set up our file handlers by reading the canister IDs from this JSON file, and we've imported the IDL or the candid interface service descriptions from this declarations file. And then we have created our default actor for testing with our agent. And then we have also fetched the root key since we are testing locally. So we fetch the root key for the agent. It is important to know that this example uses fetch root key, and this is not recommended for dApps that are deployed on the mainnet because this function is called from agent.js, and when you use this on the mainnet, this proposes a severe security concern for any dApps that make this call. So it's recommended to put this part of your code behind some certain parameters that define that it only runs locally. Since we are only running locally, we won't worry about adding additional parameters for that in this tutorial. But in the future, if you were to run this code on the mainnet, it is recommended that you take additional precautions to not use this directly on the mainnet because of the potential security vulnerabilities that it opens your dApp up to. And so now we are going to export const e2e tests backend canister equals canister IDs dot e2e tests backend dot local, and then export const e2e tests backend equals await create actor e2e tests backend canister, comma, parenthesis, curly bracket, enter agent options, curly bracket host, and then we're going to use our local URL of http 127.0.0.1 colon, and we're going to use port 4943 since that is the port that our local replica is running on, and then fetch, and then we'll put a comma after that and a semicolon after our curly and circle bracket on the end here. So now we're going to save our file, so I'm just going to use Command S to save our file. And then that is the actor for our agent. So we've just created our JavaScript agent for us to use for our end-to-end tests. So now we're going to create the actual test file. So if we go back to Explorer and we want to stay within this test directory, we want to create a new file that is called e2e underscore tests underscore backend, then .test.ts. So now we're using a TypeScript file instead of a JavaScript file. And we'll close that file explorer. And now we want to import expect, comma, tests. So we want to import these two packages from our vi-test package that we installed earlier. Then we also want to import a few things from our agent package. So we want to import actor, canister status, and the agent from DFINITY/agent. Then we also want to import the principal from definity/principal. And then lastly, we will import the E2E tests backend canister and E2E tests backend from our actor file. So from that actor.js file that we just created. And now we're going to define our test. So we're going to use test, and then this test should handle a basic greeting. Then we're going to use async, empty parentheses, equal and greater than sign for a little arrow, and then use a curly bracket and hit enter. Then we want to use const result1 equals await E2E tests backend dot greet test, and we want to expect that result1 is going to be hello, comma, hello, comma, test. And then we will add semicolons to the end of both those lines. And so what this does is it's going to import the necessary packages that we need for this test. And we are going to also import the necessary agent functionalities from that actor.js file that we created previously. And then we're going to define our test method, which accepts 2 arguments, a test name and a function. And then inside the test method, the expect is used to check that the result of this greet function, when it's passed the text test, is going to return hello, comma, test. So now if we save this file and we head back to our command line, we can use dfx deploy to deploy our canister. And we can see that we have an error here. And let's see, what is our error? So it seems to be something with the replica, since the replica has returned an HTTP error. And so I've tried to start DFX again, but I've gotten this failed to get front-end address error again. So let's take a look at the current processes. And it looks like I do have 2 DFX start processes that are running, but they also have these defunct processes after them. So I'm just going to go ahead and kill these processes. So we have a fresh start. So you can just use pkill, and then if you use the flag -9, that just means it's forcing the processes to be killed. It's similar to a force flag, and then you can just insert the process IDs of each of the ones that you want to be stopped, and then we can use dfx start clean background again, and it still says that this is in use. Let's see. So that didn't stop any of my processes. So let's just instead use kill. Okay, and now kill was able to do it. And so now I have one more. So I'll get rid of those 2. And so now I shouldn't have any dangling DFX processes running. So let's try this again. And it's still in use. Okay, so since this process is unable to start since the socket address or the port is currently in use, and so DFX can't bind to it since it's already being used by another process, we need to find out what process is currently using that port. So to do that, we can use lsof-i and then TCP and a colon for the port address. So in this case, that's 4943. And this is going to return a list of processes that are using that port. So here we can see the process ID is this 13389 value. So now if I do kill 9, it should have killed that process. So now if I use this again, we can see that it doesn't return any output. So now if I use PS again, I can get rid of our other dangling DFX processes, and we should be all good to go now. So DFX start, clean background, and now we are able to get DFX started since it doesn't have any conflicts binding to that 4943 port. So now if we use DFX deploy, we can get our end-to-end test backend canister running. And we can see that that's been deployed. And then we want to use DFX generate to generate our service description files, since those are used by our test files. So we use DFX generate, and we can see that those declarations files, specifically this .did.js file, has been generated for us. And now we can run npm test to run our tests. And so we can see it is going to return this test should handle a basic greeting. It has run our test files and our defined test, and it says that both of them have passed. And so this is a very simple test that just tests the output of that greeting function. So that's great that it's tested and passed successfully. So now we'll press Q to quit that. And now let's take a look at a more complex test. So we can create a test that checks the canister's metadata using the canister status API and returns some information about the canister status. So if we open back up VS Code and we are still in this end-to-end test backend test.ts file, we can now remove our test case that we defined before. We aren't going to remove our imports since we're going to use our imports again. We're just going to remove that test case. Now we're going to define test. And this time this should contain a candid interface, since we are going to test the candid file and the canister's metadata. And then we're going to use async, parentheses, equal greater than, curly bracket, and enter. And we're going to define the agent, actor.agent of E2E tests backend as HTTP agent, semicolon enter, and then const ID equal principal dot from E2E underscore tests underscore backend canister, semicolon and enter. And then we want to define const canister status equals await canister status dot request circle bracket curly bracket canister ID agent paths, and then we're going to use square brackets and create a list of time, comma, controllers, comma, candid, and each of these are going to be in double quotation marks, then comma, and then we're going to go down here and use a semicolon after the curly bracket and the parenthesis. Then we want to expect that canister status dot get time dot to be truthy. Then we want to expect array dot is array canister status dot get controllers, and then you'll have 3 parentheses dot to be truthy with some empty parentheses and a semicolon, then enter expect canister status dot get parenthesis candid 2 parentheses dot to match inline snapshot. And then we are going to define that snapshot. We're going to use a backtick to define a piece of code. We're going to press enter. Then we're going to use quotation marks, and we're going to write out what the candid definition should equal. So it should equal service space colon space curly bracket enter greet colon parenthesis text, then an arrow text query semicolon, and then it should end with a curly bracket, and we'll press enter and use a double quotation mark to close off that, and then hit enter again. And then we want to close both of these sets of parentheses and brackets off with semicolons. And then we will save that file. And so this test is going to check that our canister defines a candid interface. So it wants to call the canister status API, and it's going to get the candid value in the canister's metadata, and it wants that candid definition to equal this service definition here. So now if we go back to our terminal and we rerun npm test, now that we've saved that new test, we can see that it did not return correctly. It says mismatched. It expected this string of text, and instead it received this string of text. So it looks like it expected something with an indentation. So if we open back our code, it looks like I do have an indentation here, but we'll just remove that and we will replace it with space characters instead. And we'll save that again. And let's quit this and then run npm test again. And so let's hit U to update the snapshot here. And now that we have updated the snapshot, so all I did was go in and replace this. I had originally used the tab key here, but instead I just used the space bar to space it over instead, and then I saved the file again. And then when I went back to the test, I hit U to update the snapshot, and now we see that it has passed successfully. So it just wasn't reading the tab key as a correct character in the test file. And so that is going to wrap up end-to-end testing. And so we are now going to move into integration testing. So integration testing, like I mentioned before, is something that is common on GitHub in repositories that need continuous integration testing to test automated workflows. And so if we wanted to take our tests that we've just created and move them into a CI workflow on GitHub, all we would need to do is first edit the package.json file. So if we go into our IDE and we open our package.json file, we could add the line here of vi test and then run, and then define the commands that should be run in order to run our tests. And so since I copied this file directly from the one in the GitHub repository for this project, you can see that it's already in this file for me. And so the CI test is defined as vi test run. And then the commands that need to be run for this are DFX needs to be stopped if it's already running, then it needs to be started, and then DFX deploy and DFX generate both need to be run, and then this test script can be run, or the VI test script can be run. And so then to make the CI test here run in GitHub, we would need to create a GitHub folders with a workflows subfolder. So in our project here, if we just are at the high level here, we can create a new folder and call it .github. And then in this folder, create a subdirectory called workflows. And then in this, create a file called e2e.yml. And then in this, we are going to insert the following code. And so since this is defining a CI job and it's more so a definition file, I won't be typing this out like I have for the other code examples, but we can just see that it defines a test with the name end2end. It defines that the test is going to be run for different types of pull requests. So if a pull request is open, reopen, edit, or synced with the repository. And then it's going to define the environment that the test is going to run on. So it's just going to use an Ubuntu image with Node version 16. And then it's going to define the steps for executing those tests on the Ubuntu image environment on GitHub. And one of the steps for running the test is to run npm install and then run the script for installing the IC SDK, so installing DFX, so that those DFX commands that we have defined to run in the package.json file, so that these DFX commands can be run. Otherwise it will error and say that the DFX is not found when it goes to run those. So it's important to have that. And then some other environmental variables. So we'll save that. So then if you wanted to run this GitHub workflow, you would just save these files and upload your entire project here to a GitHub repository. And you can learn more about GitHub workflows in the GitHub documentation. So that will wrap up this episode of the Developer Journey. Be sure to like and subscribe to the DFINITY YouTube channel to stay up to date with all the new episodes of the Developer Journey. In the next episode, we will be taking a look at Motoko Level 2, where we will be diving into more of the fundamental concepts about coding with Motoko. If you have any questions, you can check out the DFINITY Developer Forum. The thread for the Developer Journey where you can leave feedback and comments is available in the video description, along with the links to the documentation used for this video and links to other resources such as the DevDocs homepage and the developer Discord community for live chatting with other developers. That'll wrap things up for today. Take care.